change it. I wanted to make that point with a really weird-ass set of formulas for the mean and standard deviation. Part E doesn't give a shit how weird that formula was. I took a sample. I got to change it. How is it going to change? Yeah, take what it was for individuals and then divide it by square root 43. So I don't know if you guys see the point I'm trying to make. I don't care where sigma came from. If another part of the problem says they take a sample of size blah, I better change that. It's got to become the spread for groups now. And then you do this, and then you make z-scores. Why can I use, now number 6 is what kind of distribution? Uniform. Part E, I take a sample of 43. What does that make it become? What kind of distribution is, because the sample size is bigger than 30, so now I'm dealing with a normal curve. I can make z-scores, look them up. So let me give you guys I'm going to give you the answer key. Do you want that? Yeah. So you can see on that 6E, I changed the standard deviation and then I made a normal curve and got z-scores and looked them up. Of course I would do that. So guys, real quick. Number 1, I had changed, do you see number 1 where it says -1 is the first number in the table? Everybody has that, right? Nobody has one where it says 2, the first number, right? Everybody's got -1. So past Jeff was really mean to present Jeff because I changed those numbers and I didn't, anyway. So what I did, I had to redo this side of the answer key because I was evil, and then this is from a previous semester. So 1B, let's redo 1B because you see that 45.924 number? Can you please cross that out? That was from the problem how it used to be before I changed it to -1. What should go where that 45.924 is in part B? So 1B, everybody see this? This is the bad part about practice test answer keys, because I'm human, I make mistakes too. So 1B, what should go where it says 45.924? You can kind of see how I caught myself on the mean. Right, that's the right mean, but it shouldn't be this number. What number should be there? Can you guys see what number should be there?
39.
Yeah, 39.539. So let's calculate this. Oh, Jeff. Shit. So what do you guys get for this now? Yeah, like 4.40, 4.440. That's for part B. I like it. So I apologize. So then 4D is going to change maybe just a little bit. 1D. 1D is that question I ask you all the time, right? What percentage is within a step away? So the mean was 4.453. If I take a step down, that's going to leave 0.013. Is that cool? If I take one step down from there, bam. So I subtract that from this. Now I add it. I go one step up. That's going to be 893. So on 1D, those should be the numbers. I just had the wrong standard deviation, the wrong step size. I'm averaging about a 97 on my answer keys. Yes?
Also, for A2, it's supposed to be 6217.
For negative 0.2,
Or
0.31. 6217, yeah. Okay. So instead of 6179 and 4A number 2, it should be 6. Where'd it go? 6217. I like it. So 4, 1, A, 2. The z-score should be negative 0.21 and 0.31. I understand you guys. So you see number 4?
No.
See number 4? Everybody see number 4?
Yes.
All right. Everybody see the second problem?
Yes.
The 274 to 292? Everybody see that problem? Okay. So the z-scores are that, like it says, but the area should be not 0.6179, it should be 6217. I like it. And then whatever that is. Yeah.
For 1D, it asks like a percent between one standard deviation. Is it right on the answer?
Yes.
Oh, okay.
It's just these numbers are different here, right? But what data points, I still only catch what data points. What data points are in between here
Oh.
is -1 in between there now. Is 3 in between there. Yes. Is 6 in here. Yes. So you still add the probability of 3 plus the probability of 6 because I caught all the 3s and all the 6s. I like it. Coolness.
So for percentile, we use it as a percent. For example, like
Well, that's what percentile means. Which one?
for the quiz we just had.
Yeah.
For example, the percentile 57, the 57% of the area.
Yeah, why? What does a percentile mean? So the 57th percentile means exactly what in the normal curve?
57.
Where would that be?
Yeah.
57% is underneath, so it should be a little bit above the mean. And then you just got to look at the chart because that is the area below. So the chart is actually a bunch of percentiles because they are percentages beneath something. So what I said was, you don't have to, but it helps me understand your idea, and it helps you not make silly mistakes. So you don't have to is the short answer, right? Yes.
Can you say the, like, specific definition then for the Z-score?
Yeah, if somebody got that for me, what's the Z-score mean? What does the Z-score tell you?
Oh, the number.
Yes. The number of standard deviations from the mean to the. Let me ask you this question. Does a z-score tell you a percentage? No. In fact, what would you have to use to find that? The chart, and in fact, when are you able to use the chart? If it's normal. So if I just say, what does the z-score tell you? And you say the area below something, well, that doesn't make any damn sense, because I didn't say it was normal, and that's not what the z-score tells you. The chart tells you that shit, right? So what if I ask you this? What would a z-score of 1.07 mean for a data point? That's a little more specific, but it's the same question. That data point is 1.07 standard deviations away from the mean, or even better, above the mean. I would take either one. Why is it above? Because it's positive. Yes, yes? So be ready. I'm going to ask you that kind of question. Either what does the z-score tell you in general, or what would a z-score of 1.07 tell you about a data point, right? They both basically are the same answer, just one of them is a little more specific. I'm hoping someday I'll get more than half of the class get it right. That question that I told you over and over will be on the test. Yes?
Can you explain why the of the individual or business is the same?
So I'm pretty sure. All right. Look. All right. If you let's see, this is all you do is bear with me, but bear with me. This is useful. Can you guys? Somebody give me a number. 3. Somebody else give me another number.
7.
10 and 7. Okay. All right. You can believe that I fed those people those numbers if you want to, but I didn't. This worked for any numbers anybody would give me. Help me out real quick. What's the mean of these 3? You try to do it in your head? I can do it in my head, but I don't know about you guys. You can't use a calculator.
6.66.
Yes, there we go. 6.6 forever. Right? And the standard deviation, I don't care about that. Screw the standard deviation. We're just talking about the means, right? So that is the mean of the individual numbers. Now help me out real quick. This is not going to be so quick, but oh well. If I pick 2 numbers out of this hat, I can drop it back in. I could get, for example, a 3 and then a 3, right? I can get 3 and then 3, right? What's another thing I could get? 3 and then 7, or 3 and then 10. Are you guys with me?
Yeah.
There's 3 samples of size 2. There's 6 more possibilities. I could get 7 and then 3, 7 and then 7, 7 and then 10. Or I can get 10 and then 3, 10 and then 7, 10 and then 10. So this is the concrete example of picking a sample of people from Florida and getting their average ages. I've just taken every sample of size 2 that I possibly can. Right? Right? Okay. So now let me calculate their means, because that's what this is all about. Sample means. The mean of these is 3. That's easy. The mean of these is 5. You guys with me? What's the mean of these? Not so pretty, but oh well. 6.5. Right? Add them, divide by 2. You with me? All right. Keep going. So the mean of these would be 5, 7, and then you can do it, Jeff, 8.5. And then the mean of these would be 6.5, 8.5, and then 10. If I average these averages, it will still be that you can check it. I really wish to God this would make sense. If I take each person one at a time and calculate an average age, it'll be a number. if I take 2 people, get their average, 2 people, get their average, and then average all those averages, just like that, it's got to be the same. How could it be different? How could suddenly more people be older or younger? Right? And you're all like, well, it's a few seconds. Well, shut up. I mean, you don't talk about seconds when I ask you how old you are. I am 30.2946. No. You guys semi with me? I mean, that's a good question. That's why the mean stays the same. But if you calculated the standard deviation of these, it would be much smaller than the standard deviation of this. How much smaller? Divided by the square root of 2. That is actually kind of cool. That's what that sheet with the blue and the yellow on it, that's the whole purpose of that. That looks a lot like that what I saw on that sheet. It's a concrete example of the Florida thing that we did. Now real quick, let me see. Let me push my luck here. If I put 3, 10, 7 into list 1, I can get the standard deviations. I'm going to do that real quick, and if you don't trust me, you can do it yourself. So I get a standard deviation of, and this is my population, I get a standard deviation of 2.867. Stay with me. If I do the standard deviation of all these, I'm going to predict, even before I do it, I'm going to predict that that should come out to be 2.027. I took this divided by the square root of 2 because all of my samples are size 2. And that's the formula, sigma divided by square root of n. So if I put into list 1, if I put all these means, 3, 5, 6.5, 5, 7, 8.5, 6.5, 8.5, 10. And then I calculate the standard deviation. I get 2.027, blah, 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 blah. So what this formula does is it makes it so that I don't have to make this list. Do you remember the choose thing? What was the choose thing for? So I didn't have to make the list because it gets really big. Is this a really big list? No. But can you imagine if I had 20 numbers and I want to make all samples of size 6? Right? So what if I had 3, 10, 7, 8, 4, 9? So one sample would be 3, 3, 3, 3, 3. 3, 3, 3, 3, 3, 4. 3, 3, 3, 3, 3. Holy shit, I'm not even anywhere near done with that list. That list is going to be stupid big. So I don't want to make this and then calculate the standard. I want to have a shortcut to see what the standard deviation would be, and thank God we got that sigma over the square root of n formula. It's a shortcut. So I don't have to make all the sample means. My God. My population is 5 million, and I'm taking groups of size 50. No way in hell I want to make that list. Holy shit. So that is a shortcut to figure out what the standard deviation would be if I did make the list. Yes?
Okay, I don't know if anyone else has questions about this one, but I have a question about
How's that? Is that all right? Whoever asked that? Is that? I don't know. I think I got to the point right. Okay. I even went over the point. So, yes.
Okay, so for number 6, I think I understand why it's on the key, it's like the picture of it for A, it's like the 1 6 on the side. Why is that so?
Wait. Let's try again. So 6A?
6A.
6A.
I understand where the 2 and the 8 are coming from.
Yes.
But what about the 1 6?
All right. So I want my total rectangle to have an area of what? So that it will represent all the probabilities. All the probabilities should add up to be 1. So the total area has got to be 1. If the width is 6, right? 2 to 8. How tall does it have to be so when I multiply them, I get 1, the reciprocal of 6, 1/6. 1/6 times 6 makes the whole thing have an area of 1.
And then for
Stay with me now. Yeah.
C,
See?
that-
Oh. Remember, for continuous any probability question is related to the area of that question, right? And what's the area of a line? Because x equals 5 would just be a line.
Oh, okay.
0. Yeah. And I think we talked about iota, but just it's 0. Yes.
But, wait, so uniform is,
Hell yeah.
oh,
Yeah. Because uniform, the very first example we did was like me, I can't remember, was it time looking for my keys or it was a bus stop or something, right? Bus stop. And that's time. And time is definitely continuous, thankfully, or else we'd all be skipping and that. Thankfully, we kind of go through time continuously. It's now just like, boom, I'm there. Holy shit. At least from our perspective. Anyway.
Why isn't 6 gonna be on the test?
6, D, and E
Oh, 6
won't be.
D.
There will definitely be uniform distributions on the test. The mean and the standard deviation part. Yeah, because I did think I said that wrong earlier. Definitely is going to be uniform probabilities. I'm just not going to ask you the mean and standard deviation. That would be so mean, considering I said don't put that on your formula sheet. Like,
So just completely discard this. D and E.
But what point are those trying to make? That's still making a point that if I take a sample and to ask questions about the sample mean, I've got to change the standard deviation. I don't give a shit where it came from. That's the point that's trying to make. Will you have to do that specifically for uniform thing? No, you won't. You guys know I have office hours, right?
are you sure?
You guys know I would help you with your corrections and stuff, right?
Chapter 3 homework is also due, right?
Huh?
Chapter 3 homework is also due.
Yeah, hell yeah. If you haven't turned in Chapter 3 homework, you should get that turned in. You've had plenty of time for that.
The question over.